so much. It is a pleasure to be part of this, and it's a real pleasure. I see a lot of familiar faces on my screen and familiar names, and it's great to be part of this community. As we've talked about already, there is no shortage of hype around artificial intelligence, especially since November 30th, 2022, when ChatGPT was released, and that user interface of the language models made it clear to just about anybody that this technology could be transformative, because we now had machines that could write as well as many humans. Nevertheless, we remain in a world of confusion about what we're talking about when we're talking about artificial intelligence. There is a real aspiration on the part of the tech community to create machines that can think and that can truly do everything we can do. To Chris's point, maybe someday we will get those. That is not what we have today. What we have today has been advances in machine learning, in computational statistics, that's prediction technology. And so while machines that can do what we can do to help us or take over the world may occur someday, that's not what we have in 2024. What we have in 2024 is prediction technology. So under the hood of these machines, and this is the theme of our first book, Prediction Machines, is that you should recognize that today's AI is prediction technology. Now, to understand why it's helpful to frame a technology as a drop in the cost of some fundamental input, it's useful to go through some technology history. Hal Varian and Carl Shapiro, in their fantastic book, Information Rules, talk about the transformation that happened in the dot-com wave in the late 1990s. 1995 was arguably the starting point of this wave. It was the year that the NSFNet, the US-based public internet, was privatized, the last aspects of it. It was the year of Bill Gates' internet tidal wave email, when Microsoft started to dedicate their company to making the internet consumer-friendly. And it was the year on the financial markets that Netscape had their IPO, and they were valued at $1 billion without ever having made a nickel in profit. And so the hype around the internet kept building to a point where people started to say, we can throw away the old rules. The way we used to understand the economy is wrong. Forget our textbooks, forget your econ courses. We're in a new economy. And of course, we economists pushed back on that point and said, well, no, you know what? You just need to understand the technology and understand what's different. It's not a new economy. It's that search is cheap, and communication is cheap, and copying is cheap. And for Microeconomics 101, we know the demand curve sloped downward. And so when the price of something falls, we do more of it. And when the price of something falls massively, we do a lot more of it. And so Varian and Shapiro and others started to point out the consequences of things like cheap copying. One was already obvious to just about anybody who was paying attention, which is that copyright was going to be a bigger deal, and protecting intellectual property was going to be a real challenge. A second might have been less obvious to people who weren't thinking deeply about what got cheaper, which was Varian and Shapiro and others pointed out that privacy was going to be a much bigger deal. Because once anything you say to anyone is now instantly broadcast around the world for free, you're going to be a lot more careful about what you say. So once we understand what's gotten cheaper, we can map out consequences. This idea has its roots in an economics of technology literature that in some cases precedes the Varian and Shapiro work. And Bresnahan and Nordhaus and others talked about compute. And fundamentally, what does your computer do? Feels like your computer does all sorts of things, but really, under the hood, the computer is just doing one thing, and it's doing that one thing extraordinarily well. It's doing arithmetic. Your computer is an arithmetic machine, an adding and logic machine. And with that adding and logic, it turns out it can do all sorts of things. And so Bresnahan and Nordhaus and others said we should think through the compute revolution as a drop in the cost of arithmetic. Arithmetic got better, faster, and cheaper, and that has led to all sorts of important applications of arithmetic that we might not have dreamed of before. The early applications of machine arithmetic were good old-fashioned arithmetic problems that we understood to be arithmetic problems, like figuring out the trajectory of a cannonball when it's shot out of a cannon. This was artillery tables was perhaps the fundamental use of machine compute in the 1940s and early 1950s. And we used to have humans who did that job. His job was called computer. And by 1960, humans were no longer doing those calculations. Accountants used to spend their time adding up columns of numbers. That's what they did. But with the rise of machine arithmetic and the spreadsheet, accountants no longer spend all sorts of time adding up columns of numbers. The machine does that for them. In both of these cases, note that there's still plenty of humans with similar skills doing related work. There's still plenty of bookkeepers and accountants because the people who are good at the arithmetic also happen to be good at using that arithmetic for company strategy and tax policy. And in the context of the human computers, they overwhelmingly became central to the early software industry. But around 1970, sometime in the 70s anyway, things began to change, and we realized, and we understood that a lot of applications that used to be solved with other tools could increasingly be solved practically with arithmetic. Games turned out to be an arithmetic problem. Mail turned out to be an arithmetic problem. Music turned out to be solvable with arithmetic, and pictures. Kodak was fundamentally a chemical engineering company. They solved pictures with chemistry. But in the 1990s and early 2000s, as machine arithmetic got cheap enough, we realized that we could reframe that problem, pictures, as an arithmetic problem. Now, once we start to realize that the set, as arithmetic got cheap enough, the set of problems that could be solved with arithmetic exploded to a point where we no longer thought of these as arithmetic problems. It's still nonetheless useful to understand under the hood what the technology can do. And so if you want to play a video game, especially during the early era before there was AI embedded in the games, you needed to understand that the machine had patterns. The game was based on patterns. Under the hood, it was based on arithmetic. To play video games well, you understand that the machine responds to exactly what you put into whatever input you put in. To work with computers, whether it's for CAD or any other application, you need to understand at a high level that under the hood, the machine responds to exactly your instructions. Even though you don't need to know the arithmetic deeply, the intuition that the computer is a arithmetic and logic machine is fundamental to working well with computing. So when we think about artificial intelligence, we're going to first try to understand under the hood what the technology does. And then we're going to close today with how does that help us understand the human skills needed to work well with a prediction machine. So, as I said, we should think about AI as a drop in the cost of prediction. At some point in the past decade, technological change in machine learning and computational statistics grew, increased extraordinarily to the point where machine prediction is a lot cheaper than it used to be. And that's played out in a similar way to how it did with arithmetic. Many of the early applications of machine prediction were problems that we would easily understand as prediction. Like you walk into a bank and you want a loan, and the loan officer used to look you up and down and decide based on their intuition and maybe some other things whether they should give you a loan. But what they're really deciding is they're predicting whether you're going to pay back a loan. That's arguably the oldest prediction problem in business. And increasingly, lenders are using machine learning tools. They're using AI to predict whether they're going to pay back a loan. Similarly, the insurance industry, they're in the business of pricing risk. That's what they do. They're in the business of prediction. And for the past 2 decades, they've been increasingly embedded machine learning. They've been increasingly embedding AI into their underwriting tools. But what started to happen over the past decade or so is we've realized there's a whole bunch of applications that we didn't used to think of as prediction that have been reframed as prediction. Language translation. This supposed to be an image of the Tower of Babel. Language translation is prediction. And increasingly, we used to think of language translation as a linguistics problem or a human intuition problem. We're increasingly realizing what you're doing is you're predicting the set of words in French that is the best match for English. Or, as is happening right now in this simultaneous translation, the set of words in Chinese that's the best match for the words that I'm using in English. Also, medical diagnosis is prediction. What does your doctor do when they diagnose you? They take in data about your symptoms, and they fill in the missing information of the cause of those symptoms. That's prediction. Our intuition doesn't identify these things, or may not identify these things as prediction. But increasingly, we're realizing that they can be solved with prediction tools. OpenAI's tools, the language models, are also prediction. ChatGPT, as Alan pointed out right at the beginning, is a predict the next word engine. That's what's going on under the hood. And the image generation tools are also predicting the set of pixels that's the best response to your query. For some intuition on this, if you ask for an image of an astronaut on a horse in the style of Andy Warhol, you might get an image like this. This is not a search engine. So it's not that this image was in its database when I asked for the image of an astronaut on a horse in the style of Andy Warhol. Instead, presumably, there were images of pictures of people on horses. There were images of astronauts and images of the style of Andy Warhol. And the machine, the prediction machine, identified the set of pixels, predicted the set of pixels that's the best response to a query when I ask for an astronaut on a horse in the style of Andy Warhol. Underneath the hood, again, as Alan hinted at earlier, has been an extraordinary increase in the complexity of these models. OpenAI's first model, GPT-1, used 110 million parameters. And we've had an exponential increase since then in terms of the number of parameters. This is expensive. And to give you a sense of the scope of these changes, that $1 billion that Microsoft put in the summer of 2019 led to this. ChatGPT wasn't just growing at this, it's an exponential growth, but it's just an extraordinary increase, an extraordinary change in the number of parameters and the complexity of these models. And that is what's going on under the hood to make prediction machines move from helping us predict whether someone's going to pay back a loan to writing and drawing and coding. Now, the second day of Econ 101, we teach people that when coffee gets cheap, you don't want to be in the tea business because tea and coffee are substitutes. And so many of the change in skills that you saw from Chris's presentation have a little taste of this substitution side of things. As some of the 2016 skills were no longer relevant in 2022, some of them were because they were just table stakes, like being able to use Windows. But some of them were, the machines can do that. We don't need humans to do that anymore. Tea and coffee are substitutes. So machine prediction and human prediction are substitutes. Of course, the opportunity lies in the complements. And so the question and the key thing we need to understand as machine prediction gets cheaper are what are the complements, what are the cream and sugar to machine prediction? And so what Ajay, Joshua, and I in our books have emphasized is this idea of judgment. Judgment, informally, is knowing which predictions to make and what to do with those predictions once you have them. More formally, it's the process of identifying the payoffs at the end of the decision tree. Understanding utility. What are we really trying to maximize? My favorite science fiction example to understand judgment comes from this movie, I, Robot. In I, Robot, Will Smith plays the protagonist, Detective Spooner. And Detective Spooner hates robots. The reason he hates robots is some years ago, he was in a car accident with a little girl. And for whatever reason, both Detective Spooner and a little girl are about to drown. And a robot comes along and saves him and not the girl. And that's why he hates robots. Because it was a machine, importantly, he could audit it. He could figure out, why did the machine save him and not the girl? And the machine predicted that he had a 45% chance of survival, and the girl had an 11% chance of survival. And 45 is more than 11, and therefore the machine saved him and not the girl. Detective Spooner goes on to say, but 11% was more than enough, and a human being would have known that. Well, that's a statement about values. That's a statement about judgment. The machine just had a prediction of 45 versus 11. Some team of fictional human engineers at some point in the past embedded that machine with the values that a life is a life. To say that all lives are equal is judgment. And that, even in this science fiction example, required somebody to tell the machine what mattered. That process is embedding judgment into the AI, and that remains a fundamental human role in deploying AIs. It's not just in science fiction, right? So AI can change the time and place of judgment. It's still judgment, but instead of the rescuer on the ground deciding on the relative value and who to save, it's the engineers who embedded that in the machine some time ago and in a different place. When we hear that machines are hiring and firing people, it's the same idea. When you hear that AI is you're deciding who gets a raise, who gets promoted, or who gets fired, that is a team of HR managers or engineers at headquarters deciding that their judgment on who gets hired and fired and promoted is better than the individual managers on the ground in each of those organizations. So what this is in each of their stores or restaurants or warehouses, right? So what AI is enabling is a change in the people who gets to decide, whose judgment is embedded in very consequential decision-making. And in this context, it's centralizing away from individual managers on the ground in restaurants and stores to headquarters. So, AI can actually change the core decision makers within a company, sometimes expanding the scope of decision power, and sometimes the opposite. Now, what's happening with the language models and the rise of generative AI under the hood is it's important to recognize the fundamental role of human judgment in building these models. So how, for example, was ChatGPT trained? Well, first you had a human labeler demonstrating desired output, desired behavior. Okay, so as part, in addition to the corpus of all text on the internet or wherever it was found, there was a human giving examples of good and bad responses. Okay. And then perhaps more importantly, the labeler, so in response to various queries, a human labeler ranks the outputs from best to worst in terms of whether they're honest, helpful, and harmless. So OpenAI has decided that the important values in a language model are that it's honest, as in it tells the truth, that it's helpful, as in it tries to respond to whatever you asked for, and that it's harmless in that it doesn't offend anybody. Importantly, those three values are often at odds. Sometimes honest feedback can offend. Sometimes the model may not have a good answer, and so it may not be able to be helpful. And so it has to decide to be, or maybe a helpful response is mean, and so it's not harmless. And so the values that the leadership of OpenAI embedded into their machine involve a weighting of the importance of honest, helpful, and harmless. And so what you need to recognize when you choose a particular AI model, a particular language model, and image and video is going to have the same phenomenon, is that you are choosing the judgment, the values of the leadership of those companies. And OpenAI's model gives you very different judgment, very different values than Grok, and then Anthropic, and I assume then Ernie, though I don't know on Ernie. And what you need to, so if you're a company delegating some decision-making to an LLM, you're not delegating decision-making, you're not delegating the judgment to some machine. What you're doing is delegating that judgment to another company, to a large tech company, and the values that are embedded in that company. So AI can move judgment out of one company and to another. And so what you need to understand, the reason you need to understand that AI is a prediction machine is first it's that data is a core input to that. But that I think is obvious to most folks. But more subtly, this important role of judgment means that AI can change the time, place, employee, division, or organization that drives decision-making. Thank you.